TTL Computer 2. Today will be part 2 of our video for creating the permanent power supply for our TTL Computer 2. And I just wanted to revisit the schematic of our control circuit. In video 1, there was a small error in the wiring diagram here on these two transistors. And this has been corrected in this diagram. I also posted it to the community pages. But I didn't want to spend a few seconds talking about this diagram, just a little bit more, and about the 200 millisecond delay that we have for the being in the low power before we switch into the high power phase of the power supply. And some of the reasoning behind how did I get to that 200 millisecond delay. And so I totaled up all the capacitance on our power decoupling capacitors on all of our boards, and it came out to about 2,000 microfarads. So I used that to calculate the approximate charge time for those capacitors, and it's only about a millisecond or 2 milliseconds for those capacitors to charge. So that's really the only amount of delay that we needed. But I wanted to go longer than that. So that's our lower limit on the low power on the charge delay. We have an upper limit too, is we know that the reset circuit on our TTL Computer 2 um, holds the computer in reset for about a second. It's a little bit more than a second. So that's our limit. We have a lower limit of 2 milliseconds for the capacitors to charge, and we have an upper limit of about 1 second where the computer is going to be, right, the reset circuit is going to let the computer begin to run. So I came up with the 200 millisecond delay, or 2/10 of a second. So that's way more time than is needed for the capacitors to charge, and is also brings it to full power and for the power to stabilize, before the 1 second timer runs out on the reset circuit. And I like that it's the 200 milliseconds too, so that if you look at the LED power indicator when the power supply is turned on, you can actually see the change in intensity. So you get a little visual confirmation that the power supply, is cycling from the low current to the high current phase. So it's nice to have that little visual indicator, and that's kind of the reasoning as to how I got that 200 millisecond delay. Okay, so let's go on to the rest of our build. So we realized, this circuit board build in our last video. So now you can see we've added in our 5-volt, 10-amp power module here, and that's alongside of our current control board that we built in our last video. And I have these both secured down and mounted to just an acrylic tray. And you can see here that this is the base of our enclosure, and I've already pre-drilled this with the mounting holes that are necessary for this board. Okay, and now we see that we have that board is now mounted, is mounted to the base of our enclosure, and that fits nicely, but it's tight. It's tight. When I ordered this enclosure, I thought the enclosure was going to be a little bit large, but it actually ends up being a little bit tight, and we'll see that as we do the rest of the build out. Okay, so here I've just drilled the back panel of the enclosure for our AC plug and our power switch, and those are mounted to the back panel. Here I'm just test fitting that in. We see how that fits in to the enclosure, and so here's the AC connections, and right here are the power connections where they need to go to the modular power supply. Okay, and this just a test fit. We see how that looks in the back of our enclosure. Okay, so now we're starting to wire in the rest of the fixtures here to the actual power supply elements. We see we have all the AC elements connected here. We have the main line the hot line going to our power switch, and that's connected in. Now here you can see we have the rest of our AC mains are wired, and here we have uh, the main line comes in, the hot line comes in, goes through our switch, and we can see right here that I've used an inline fuse. So we have two fuses in our power supply. We have this 1 amp fuse on the high voltage side, and then we have the 4 amp fuse on the 5 volt power supply side, which goes to TTL computer 2. Okay, and here we're just I'm doing my first test of the assembled power supply, and you can see that I've used again a 5 ohm 10 watt resistor here as a shunt resistor, and that's hooked up to the oscilloscope, and we see that we have our stair step pattern on the power supply startup, and that all looks good. Now here, I'm working on the front panel, and I've installed the LED power indicator in the front panel, and I'm also using Anderson power pole connectors as the main connector for the power supply. And you can see some of those sitting here. I use these Anderson power poles as my main interconnects for many of my projects, and it's actually kind of a little interesting thing to look at, and we'll do a separate video probably over the summer, might be my next video, to just talk about these in a bit more detail and show you how I use them and how they're pretty versatile. Okay, so this is our completed power supply. So it's all sealed and in our enclosure, and we can see our power light is on, and our output voltage is 5.125 volts, which is just what I have tuned it to. So using the modular power supply, you can adjust the output voltage, and I've adjusted that to just a little over 5 volts, just to accommodate for the voltage drop that we have, in our lines and in the board and all the board of all the 10 boards of the computer. Okay, so we are ready now to take a look at powering up TTL Computer 2 for the first time with our new power supply. And you might want to keep an eye on the power supply indicator light. And if you look at that closely, I said you can see that intensity change. It'll come up, it'll go on and then it'll get bright. So you can actually see a visual indicator that of the two-stage power startup. Okay, so we're going to just power up our new power supply. And we're going to take a look that we have a clean startup of the computer. And yeah, that's our main goal for right now. Okay. Power. And that's good. And we can see here that we went through had a little bit of a different startup than usual. So we start up, and the first thing the computer does is it runs through a system check. And we can look at that again by doing a go to 0, and that'll do the system check again. You'll see that it starts up, and then we'll watch the system check. About every second it will go through different step. Check, 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 check. Okay, done. All right, so what that does is it just spins through, outputs to the let's see if we can't, we're going to go handheld, and then we'll take a look and see if we can watch what's going on the computer. Okay, so we're going handheld, so I'm kind of on a weird angle because we can see the LED displays, the hex display, and we can also see the two LEDs on the back end of the computer on that first board. We can see them, and it's going to cycle those too. So I'm going to hit reset, and then I'll go through the check sequence. We see the counter, and both of the LEDs are going, and that's done. So all that does is it cycles through. puts the LEDs on, and it also does some memory checks, reading and writing to memory. And if that's all okay, everything just zeroes out. But if there was an error, we would see that on the display, right? Instead of okay, we would see an error message reported. But that's it. That's our startup sequence. That's our new power supply, and that's all good. Looks good to go, and I think I'm ready for the next leg up on TTL computer, which is going to be quite a lot of software development work I'm going to need to do. But that's it for today. Until next time, thanks for watching.